Okay, so the last part here we're going to talk about is finding oblique asymptote. Okay, and in order to do that, we need to do long division. Okay, so just to kind of refresh your memory on division. Okay, so remember, we want to find the highest multiple of 3 to get to 4. So that's only 1, right? So 1 times 3 will give us 3. Then we subtract. So we get 1 here. 4 minus 3 is 1. Then bring down the 8. We get 18. All right. And then we're going to, again, find a factor that we can multiply to 3 to give us 18. And that would be 6. So 6 times 3 is 18. Subtract, and that'll give us 0, right? So the remainder here is 0. Okay. So we're going to follow the same process as we did in this uh, particular case in the long division, okay, for a rational function. All right. So let's see here. Use a different color. Okay, so we're gonna have our x cubed minus x squared plus 1 on the outside here, and then we'll have the 3x 4 minus x squared. Okay. So in fact, I'm going to backtrack here a little bit. I'm going to rewrite this in a different way. So again, what we want to do is we want to divide 3x minus 4 minus x squared over x cubed minus x squared plus 1. But notice that I have some missing terms, right? Some gaps here. So what I'm going to do, I'm going to put some placeholders there. I don't have to do that, but it does help when I'm doing this long division. So I'll have 3x4, okay? And then I'm going to put a placeholder. So I'm going to have plus 0x to the third. Then I have the minus x squared. Then put another placeholder, 0x, all right? And then plus 0, all right? And so again, that just helps me as I do this long division. Okay, so what I want to do here is I want to match, okay? I want to match the leading terms. So I have x cubed and I have the 3x4. Okay, so I want to match these guys, x cubed and then 3x4. So what can I multiply to x cubed? Okay, that will give me 3x4. Correct, right? 3x. So that's what I'm going to do. So I'm going to have 3x, and I'm going to multiply x cubed minus x squared plus 1. Okay, and I'm going to put that information in this row. So I'm going to distribute this. So I got 3x times x cubed will give me 3x to the fourth minus x squared, okay, plus 1. Oh, sorry, backtracked. 3x cubed, 3x to the fourth minus 3x to the third plus 3x. There we go. All right, then we subtract that. So 3x to the fourth minus 3x to the fourth is 0. 0x cubed minus 3x cubed is going to give us a positive 3x to the third. We bring down the negative x squared. And then this is going to give us 0 minus 3x. So that'll be a minus 3x there. Okay. All right. And then we go through the same process again. Okay. But this time, make sure we put in our 3x here. Okay. So now we're going to match this leading term. We have the 3x cubed with the x cubed, right? So what do I need to multiply to x cubed to give me 3x cubed? Perfect, a 3, right? So we need to multiply this by 3. So 3 times x cubed minus x squared plus 1. So I distribute that. So that gives me 3x to the third minus 3x squared plus 3. Okay. All right. So then I subtract. Pause here for a second. Okay, so when we subtract this, we're going to get 3x cubed minus 3x cubed is 0. Then we have minus x squared, that's a minus here. Minus x squared, a negative and a negative is a positive, so that's going to give us a positive 2x squared. Okay, and then we have minus 3x, then a minus 3. So, okay. All right. So then don't forget to put plus 3 here. Okay. All right. Now, once this term here, x cubed, is bigger than the result here, the remainder, okay, then we stop, right? So in this case, the third power is bigger than number 2, the power here, then we stop. We don't go any further, okay? So this here would be our remainder, right? But that's not what we want. We want this here, okay? The 3x plus 3, okay? So this is going to be our oblique asymptote. The oblique asymptote is going to be y is equal to 3x plus 3. Okay, but if we're just doing regular long division, our answer would be 3x plus 3, and then the remainder would be this, whatever is left over. Okay, all right, but anyway, that's not what it wants. It wants us to find the oblique asymptote, which we did, and that's derived from whatever result we got from the top part here. Okay, so that's our answer there. All right, so this one again, we're trying to find an oblique asymptote. How do we know we have an oblique asymptote? Is because the power on the top, 3 is one more than the power on the bottom. Okay, so that's why we know we have an oblique asymptote. So, so again, what we want to do is we want to match the leading terms here. So we have x squared and x cubed. So let's go ahead and write this out here. So we have x squared minus 5x minus 14, okay? And what we want is we want to multiply this x squared so we can get an x cubed. So that's going to be an x, right? Because x times x squared is going to be x cubed. So that will be x cubed here. And then we're going to do that for each of the other terms. So that's going to be minus 5x squared and then minus 14x, right? So again, I just put these placeholders here so that I'm able to subtract them or line up the terms directly under each other. Okay, but again, it's not required. All right, so when we have that, we get x cubed minus x cubed is going to give us 0. Then x squared minus minus is going to be a positive 5x squared. And 0x, again, minus minus is going to be a positive 14x. And then we'll bring down that 1. Okay, so in this case, the first number we have or term is x. All right, so we put x there. Okay, so then we keep going. The power here is still either bigger or equal to the power down here, so we keep going. When it gets to the point when it's less than, all right, to the power down here, then we stop. Okay, so we do it again. So we have x squared minus 5x minus 14. Okay, and we want to match it to the 5x squared. So that means we need to multiply x squared by 5 and then distribute. So 5 times x squared is going to give us 5x squared. And then we'll have a minus, what we have here, 5 times 5 is 25, so minus 25x. And then 5 times negative 14 is going to give us a minus 70. Okay, and then we subtract. So 5x squared minus 5x squared is 0. 14x minus minus is a positive, so that's going to give us a positive 39x. Okay, and then plus minus minus will be a positive 71. Okay, so this is going to be our remainder, but that's not what we want. We want the expression here on the top. So don't forget the 5 that we just got. All right, so this is the answer that we want. So what does this mean? It means we have a oblique asymptote at y is equal to x plus 5.